p-value is low, when p-value is low, low means lower than level of significance. For a 5% level of significance, it is 0.05. For 1% level of significance, it is 0.01. For 10% level of significance, it is 0.1. Whenever p-value is lower than the level of significance, null will go. That means you reject the null. When you are rejecting the null, you can believe that no, the X factor which you are suspecting has an impact on the bill. So the factor is critical. Suppose if the p-value is not lower than the level of significance, it is higher, then null will continue to stay. You cannot gain confidence on the significance of the factor. The X factor has no impact on the Y response. So when p-value is less than 5%, you reject the null. When p-value is more than 5%, you do not reject the null. So this is the decision making criteria. So this is what we have studied here. For average, we used the continuous data, and see here, when you compare a sample average with the population average, and when the standard deviation is known, that is one sample Z test. You compare a sample average with the population mean, but standard deviation is not known, it is one sample T test. And sample A compared with sample B, that is two sample T test. And you more than two groups, when you have same situation for more than two groups, that is ANOVA. Similarly, proportion, one proportion means a sample proportion compared against population. That's called one proportion. And two sample proportion are studied. One sample proportion is a proportion of sample A with the proportion of sample B when you are comparing. That is called two proportion test. And same situation when you have more than two groups, that's called chi-square test. And similarly, instead of working on average as well as the proportion, sometimes you may have to take a decision on the variance, whether the variances are equal or not. When there are two groups and variances are equal or not, that's called F test. When there are more than two groups, there are two options. You can go for Bartlett test or Levin test. And similarly, sometimes you may be interested in studying the relationship also, whether a relationship is linear or not. And we have hypothesis testing called correlation, which will tell us whether a relationship really exists or not. And sometimes, we may also wanted to understand whether the relationship is linear or relationship is quadratic or cubic. And that question will get answered using the test called regression test, right? And all these things we are going to discuss one by one with some examples, then you will understand. So this completes the terminologies related to the hypothesis testing, type 1 error, type 2 error, and different types of hypothesis testing. And now maybe you can ask your questions to gain more clarity on what I've explained so far, and then we can move on to the case studies.